Let's take a look at some more examples of how we can simplify square roots. Now remember, it's helpful to have a list of perfect squares if that's the method you're going to use. So if I make a list of perfect squares, remember 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 49, 81, 100. I stopped there on the last page of notes, but I could go 11 times 11 to get 121 and 12 times 12 to get 144. And it keeps going because I could do 13 times 13 or 14 times 14. So having that list of perfect squares can help because if I say it's 28, which one of these numbers is a factor of 28? 4 is. And I can rewrite this as 4 times 7 and rewrite it as the square root of 4 times the square root of 7. Well, what is the square root of 4? Always start with that question. Well, the square root of 4 is 2 because 2 times 2 equals 4. Does 7 have any perfect squares that go into it? Before you say no, it actually does. It has a 1, but 1s don't count. 1's going to go into every number. It's not going to help us break it down. So if that has no more perfect square factors, we're done. And that is the square root of 28 simplified. Now, using the factor tree method, if I break 28 down, you could go 2 times 14, and 14 is 2 times 7. What you do is if you write it in order, every time you see a pair, if we want to take the square root of this, you just drop that down because 2 times 2 is 4. So if I'm taking the square root of 4, it's just going to be 2. And then you can bring anything that doesn't get circled, I always circle pairs, and that stays in the radical. And you'll notice that's just another way of getting there. Again, I like this method more when the numbers get bigger. So let's make the numbers bigger. The square root of 128. Now, remember the perfect square method means we want to break this down into something times something. Now you might look at these and you might say, I don't know what perfect square goes into it. So what I do is I can divide these out. So I'm going to take 128 and I'll divide it by 49. No, I missed a perfect square over here, didn't I? I hope you guys caught that. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. I'm so sorry about that. And 9 times 9 is 81. I'm sure you caught me. So if I divide this by 81, I get a decimal. Doesn't work. But if I take 128 and divide it by 64, I can see that it goes in there 2 times. So I am going to go the square root of 64 times 2. And then I can break this down, see it, to the square root of 64 times the square root of 2. Now what number times itself equals 64? Is this a perfect square? We know it is. That's 8. Does 2 have any perfect squares besides 1? No. So that's the quick, short way to get there. If you find that 64 and you don't forget it on your list. But what if you picked out a different perfect square? What if you were doing this and you said, you know what, I wonder if 4 goes into it. And it does, 32 times. What you can do is you can write this as the square root of 4 times 32. Square root of 4 times the square root of 32. Now, what is the square root of 4? Again, we're pulling out all perfect squares. That's 2. Now, does 32 have any perfect square factors? Well, if you look here at your list, 16 goes into 32. So I could rewrite this as the square root of 16 times 2. So we get 2 times the square root of 16 times the square root of 2. And see, you kind of want to be neat with this and make sure that you keep your square roots over the numbers. So this becomes 2 times, well, the square root of 16 is 4, because 4 times 4 equals 16. And then we look at 2. Does 2 have any perfect square factors besides 1? Nope. Then we're done there. And what you're going to see is if we go 2 times 4, we get 8 times the square root of 2. Again, we got the same answer. This one took a little longer, but we still got there. Now, I want to show you a factor tree method. So if I take 128, and maybe I say, you know what, I'm going to break that up as to 2 times 64. And I'll break 64 up into 8 times 8. And I'll break 8 up into 2 times 4, and 4 into 2 times 2. And you just kind of keep going with this. I always circle my prime numbers. So what you do is once you have circles all at the bottom, write it all out. I have 1, 2, 3, 4, 5, 6, 7 2's. 1, 2, 3, 4, 5, 6, 7. Now, the trick is to circle the pairs. I'm going to circle 2 times 2. Why? Well, 2 times 2 is 4, and if I take the square root of that, the square root of 4 is just 2. I'm going to circle another pair of 2's to give me another 2, and another pair of 2's to give me another 2, and then notice I have this one lone 2 left over, so he stays under the radical sign. 2 times 2 is 4. 4 times 2 is 8, and look at what we get. 8 square roots of 2. So just kind of keep going with it. You'll get there. All right, the last one I'll show you real quick is the square root of 250. So with my perfect square method, if I go to my perfect squares here, I'm going to see that 25 goes into it. So I can rewrite this as 25 times 10. So that's the square root of 25 times the square root of 10. 25 is a perfect square. The square root of 25 is 5. Does 10 have any perfect square factors besides 1? Nope. So that stays the square root of 10. And if I wanted to, one last time on the factor tree method here, I could just break this down using whatever factors I know of. And again, once you get to the end, you write them in order. I have 1, 2, and 2 5s, and I'm going to see that I circled one pair of 5s. So I know I'm going to bring that out here, but then this 2 and this 5, I have to write under square roots. And kind of go in reverse of what we do here, we would still get to the same answer. So, simplifying square roots. The purpose of it is if you don't simplify them, you're going to have to, if you put it into a calculator, you're going to get an irrational number, and we're going to have to use an approximate sign. And later on in math, the reason you have to simplify them and not just leave them as big numbers is because, of course, you're going to be doing more with them. You're going to be dividing things out. So being able to simplify this is going to help you later on when you get into more complicated problems.